Okay, thank you all for tuning in. My name is Daniel Azuma, and this session is Serverless Rails, Understanding the Pros and Cons. And this is my cat. Since we're all at home, our kids and our pets demand screen time. Yeah, right. All right, down you go. Come on. So, we're going to discuss how Rails interacts with serverless hosting. When should you or shouldn't you use a serverless product to deploy your Rails app? And if you do, how should you write your app so it'll thrive in the serverless environment? Now, these are important questions for us to talk about because serverless is kind of a hot new thing right now. Right? There's a lot of interest. And to be honest, there's a lot of hype. We've been hearing these promises, zero ops, outsource your infrastructure, automatic scaling. And while these are exciting possibilities, we also need to understand the trade-offs. This is your app in production. It's important. So we need to approach questions like these in a principled manner. Now, this is important to me because I work at a big cloud provider. I'm the lead Ruby engineer for Google Cloud. And as such, I've worked on some of these products. I've worked with our customers. And I've seen the response in our community when we make serverless announcements. And it's been really interesting. We released Ruby support for Google Cloud Functions not too long ago. And one of the first questions I got asked was, how do I use this to deploy my Rails app? And in all honesty, I wanted to respond with a different question. Do we really want to use this to deploy our Rails apps? Why do we want to use it? What benefits do we really expect to get out of it? What do we think the trade-offs will be? And are we even asking questions like these? And how do we find answers? So we're going to spend this session really taking a critical look at serverless hosting. And we're going to get started with the term serverless. And you know what? I'm going to come right out and say this. The marketing people at my big cloud provider are not going to like this, but we got to be real here. Serverless is a terrible term. It really is. It's terrible. It's terrible for several reasons, not the least of which is it's a lie. I mean, everyone knows it's not really serverless. Of course there are servers involved. Underneath all the frameworks and all the virtualization, ultimately you're still running on one of these things. And ultimately what you're paying your cloud provider for is one of these things, right? Your usage of this. So let's be real here. Serverless is a lie. And that's not the only reason. Serverless is a terrible term because it's imprecise. No one really knows what it really means. I mean, what's serverless and what's not serverless? So we just end up with a lot of bike shedding on Twitter, right? Is Kubernetes serverless? Well, not really. What if it's hosted and managed Kubernetes? Well, see, it's not a useful term. It's a lie, and it's not even a useful lie. So you know what? We're not going to mention the words serverless again for the rest of this session. Yes, you heard me right. I'm going to pull a bait and switch on you. You thought you're going to come and learn about serverless? I'm not even going to use the word anymore. Instead, we're going to drill down into what the real issues are. I mean, what are these products really trying to accomplish? How do we think about the differences, and what does it mean for a real-world Rails application? We're going to start by turning the Wayback Machine a bunch of years. Back to 2006. 2006, I was co-founding a startup with some friends. And I just convinced them that we should build our product on this brand new framework called Ruby on Rails. It had just gone 1.0. It was all the rage, very exciting. Now back then, we didn't have cloud platforms, not like we do today. There were a handful of hosting companies, there were co-location spaces. A lot of us just installed our own hardware. And so when it came time to deploy our app, well, that's what we did. We bought our own hardware. We bought a bunch of rack servers, and then we set them up in the colo space in the server room. Now this is not our server room. This is actually a Google data center. I thought I had photos of our server room, but I went searching through my hard drive and I couldn't find any. So I went and emailed all my former partners, and no one has any pictures of our old server room. It's really sad, actually. If you start a company, make sure you get photos of everything. I mean, everything. Otherwise, 15 years later, you're going to want to tell stories in a conference talk like this, and you won't have photos, and it'll be really sad. I miss that server room. I remember I used to spend Christmas Day in our server room. We'd use that day to do disruptive upgrades like reconfiguring the network or upgrading the OS on key servers, because we figured that if we needed to do downtime for our product to do that kind of maintenance, Christmas Day was probably the best time to do it, right? Because unless you're Zoom in a pandemic, probably no one's using your product on Christmas Day. So we bought a bunch of servers, and we bought hard drives, and we installed them in the servers. And we installed Linux onto those drives from CDs, right? We bought a switch, and we plugged together a network, and we made sure our Rails app was installed and running. And sometimes we're doing all this on Christmas Day, and I wish I had photos. Well, a few years later, something new came out. Amazon Elastic Compute Cloud, Amazon EC2. Now this was a revelation. We could log into a web console, and then we could procure servers and procure hard drives and connect them to our servers and install Linux and configure a network and make sure our Rails app was installed and running. And sometimes we still did this on Christmas Day. Okay, it basically was the same kind of thing we were doing before. I mean, I didn't have to drive half an hour to a colo space and spend all day in the noisy server room. But otherwise, it was kind of the same. You know what? That's what was so brilliant about EC2 when it came out, that it looked the same. See, these cloud servers had the same components as physical servers: CPU, memory, disks, network connections. They had the same lifecycle, boot process, shutdown process. They had the same capabilities, same operating system, same properties. All these concepts were familiar and predictable. They were the same in EC2 as in physical servers. The underlying implementation was very different, of course, but how your deployment and how your app interface with all of it, that was basically the same. See, what AWS had done was to give us an abstraction of a server. They took the idea of a server, all of its components, all of its properties, all of its quirks, and they created an abstraction. They made this virtualized thing in the cloud, and they made it look the same as a physical box in a cabinet in the server room. And it's almost 15 years later now, and today I don't know if we really appreciate how brilliant this was at the time. As software developers, we're familiar with abstraction. We use it in our code all the time. But this was a revelation, this large-scale abstracting of infrastructure. And it's crucial to understand this, because what's happening today, now with these new hosting products, is they're creating new abstractions. They're creating new infrastructure abstractions, and we have to understand that in order to understand how and when to use them. So let's take a look at a very different kind of cloud service: functions as a service. Amazon released Ruby support for Lambda a couple years ago. Google recently followed suit with Ruby support for Google Cloud Functions. I don't know if Azure Functions has official Ruby support yet, but anyway, these are all very similar products that are based on a common abstraction, that of a function. Now, what is a function? Well, we know what a function is in software. It's a piece of code that takes arguments and returns a result. Most programming languages have them, or something similar. Now, functions as a service is based on the observation that web applications also look like this. A web app is basically a piece of code that consumes a web request and returns a web response. So we can model a web app as a function. Therefore, we can also write a web app as a function. This is a simple web app in Google Cloud Functions. It's a block that takes an argument and returns a result. Lambda would be similar, slightly different syntax, exact same concept. Now, when we look at this, notice what's not here. In Rails, you have a routing file, routing config. Here, there's no routing. In Rails, you have controllers. Here, there's no controller. A function is just an argument and a result. Routing is not part of the abstraction. Controller is not part of the abstraction. Even more fundamentally, there's no disk in a function. A function is data in, data out. Disks are not part of the abstraction. Indeed, neither is CPU or memory or network or operating system not part of the abstraction. Well, that's kind of a weird thing to say, isn't it? Does this mean that a function can't access a disk or can't use memory or CPU? No, of course that's not what it means, but you do need some CPU and some memory in order to run your code. But what it does mean is you might not be able to make assumptions about the behavior of these elements. You see, an abstraction is a contract. It's just like a contract in code, an abstraction in code. It's an agreement on how different parts of the system will interact. And like any agreement, it covers certain things and not others. So functions cover arguments, but not disks. Now, things that are not covered may still be there. You just don't have an agreement about them, or you don't have the same agreement about them. You can't make the same assumptions about them that you might be used to. So let's consider an example. When you deploy to a physical server, so an actual physical box, it's probably safe to assume that no one is going to swap your CPU out while your app is running. Right? If this is a physical box and it's turned on and it's running, no one's going to open it up, pop out the 20-core CPU, stick in the 10-core CPU in its place, all while the thing is running. Right? That's just understood. It's an unspoken contract. Everyone knows that's how servers work. The CPU you started with, when you boot the thing up, it's the same CPU you'll have all the way until you shut it off. So chances are you've written your Rails app with that assumption. Chances are you've written your app assuming that CPU will be consistent. So when you start up your app, you might do something like spin up a fixed permanent set of worker processes, or threads, or even background processes. You might spin those up based on the number of cores that you know your server has. And you know those cores are not going to go away while your app is running. If you run on virtual machines on a cloud platform, they generally adopt that same server abstraction, including that agreement that the CPU is not going to change. It's understood. It's part of the contract. But when you go to functions as a service, the CPU is not part of the abstraction. The function abstraction does not give you that same guarantee of consistent CPU that the server does. In fact, most functions as a service offerings will explicitly say that they will alter your CPU allocation while your app is running. They might even turn your CPU completely off during times when you're not actually in the middle of handling a request. And we'll talk about why a little bit later on. But this means that you cannot write your app in the same way. You cannot spin up a fixed permanent set of workers or threads or background processes because you cannot assume that you'll be given that constant CPU. The disk is another common example. Some Rails apps write files into the app directory, maybe caches, logs, even application data. And this usually works fine on a virtual machine because, again, a server abstraction is expected to have a disk. That disk is expected to have certain properties. But a function abstraction does not have those same expectations. As a consequence, the app directory might not be writable. It might not even be available in the same way that you expect on a server. Well, this doesn't sound very good, does it? No CPU, no disk. Why would anyone want to use something like this? And it's true. Functions give you fewer guarantees. You can make fewer assumptions. But the flip side of that is you also have fewer responsibilities. So let's think about CPU again. When you deploy your app to a VM, you're given a certain amount of CPU. You're going to get charged for that CPU, whether you use it or not, because it's yours. And it's part of that server abstraction, that agreement that was given to you. And you are responsible for managing it from that point. Of course, chances are you're not going to be able to utilize all of your CPU because traffic fluctuates, it goes up and down. So we all know we're probably paying for CPU that we're not using. And we shrug, oh well, that's life. That's just how things work. That's how servers work. In a function, you're not responsible for CPU utilization because CPU is not part of the abstraction. So all this goes away. Your app will be given CPU to execute your function. And that's all you need to know. Rather than being responsible for all the CPU, you're given CPU only for your function, and you're charged only for your function. You pay only for what you use for that function. And that can save you money. And of course, your cloud provider might be trying to schedule these functions and pack them in so to utilize all that CPU, but you don't care. It's not part of the abstraction. It's not your responsibility. So things are simpler for you. And indeed, a lot of things become simpler. Not just the resource utilization, but telemetry, measurement becomes simpler. Error recovery, scaling, security, all of DevOps will tend to get simpler and more efficient because the abstraction that they're working with is smaller. So we're seeing some trade-offs here. Fewer guarantees, but fewer responsibilities. When we think about these trade-offs, it can be useful to visualize what the different abstractions are concerned with and how those relate to your Rails app. So remember, servers are concerned with resources like disks and CPU down here near the bottom of the stack. Functions are concerned with stuff that's way up there in the application logic. And there's a wide difference here. Functions and servers are polar opposite ways of modeling that interaction between your app and its environment. Now, we've seen some of the consequences of that. But yeah, functions are a pretty radical change. So that brings up a question. Is there a less drastic option? Yes, there is. And that brings us to another important abstraction, the container. Now, many of you might be familiar with containers already. A number of hosting products use them, including Fargate on the Amazon side, Cloud Run on the Google side, of course Kubernetes in its various forms. But they're also an abstraction. Containers are another way to model the interface between a program and its surrounding environment. So let's take a look at where containers live in our diagram here. A container wraps an application process. It also wraps all the dependencies and the resources that that process needs in order to run. So it's concerned with these things. These are part of the abstraction. They're part of the agreement. Now notice that there is some overlap here between containers and servers. They model some of the same things, but not all of the same things. Containers are not servers. They're not concerned with low-level resources like the disks or the network. They're also not concerned with the server lifecycle. Again, not part of the container abstraction. So what are the implications of this? Well, here's one example. If you deploy to a server, it's common practice to start up your Rails app at boot time, right, as part of an init script for Linux. Now, booting up a Linux box, or pretty much any computer for that matter, it's understood to be slow, right? Things have gotten better over the years, but it's still a slow, heavyweight process. And it can be that because it happens infrequently. You're not rebooting your machine all the time. So if you start your Rails app as part of this boot process, then it's probably okay for the Rails initialization to be kind of slow. And indeed, it does tend to take its time. It's common practice for Rails initialization to be used to set up connections or to warm up caches and so forth, time-consuming tasks. But the container abstraction is different. Containers don't include that long boot process. Containers are understood to be lightweight, cheap to start up and cheap to shut down. And so that happens much more frequently. That means if you're running in a container, you have to pay much more attention to your app's startup time. We call this the cold start time in cloud speak. Cold start needs to be fast because it's going to happen often. And that's going to affect your app's perceived performance. Another example, when you're running in a server or a VM, it's common practice to fork a bunch of worker processes, right? So you can utilize all of your CPU cores. Again, because worker utilization is your responsibility. Now things are a bit different with containers. The abstraction is less concerned with CPU, much more with processes. So the general best practice with containers is to run only one worker per container. So again, because containers model different kinds of things, that affects how you deploy, and even how you design and how you code your app. So we've talked about some of the new hosting abstractions and some of the ramifications. Now it's time to tackle the question that we all actually came here for. What about Rails? What does all this tell us about deploying your Rails app? So let's think about Rails. Rails is a monolithic framework. It does a lot for you, and it has a lot of different components. You have model view controller, structuring how your app responds to web requests, and that lives up there. You have active record, your data layer, and it includes logic, but it also mediates connections to your database. That could be locally or over the network. You have other components like active storage, where you can store data on your disk or in some remote storage service. You have caching, which might be to disk or to another local process like a memcache, or to a remote cache over the network. You have active job, a way to manage background jobs, locally or remote. Instrumentation, where you can make measurements of all sorts of things taking place at runtime. Rails integrates with a web server like Unicorn or Puma or Passenger, and that manages processes and workers and threads. We saw before that there is an explicit initialization process that sets all of this up. And of course, Rails provides hooks for plugins that enhance its capabilities up and down the entire stack. So you see, Rails is a full meal deal web framework. It manages everything. And that's one of the reasons it's been so successful over the years, because it manages everything in the stack. It gives you everything you need in order to build a powerful app on a web server. But the flip side of all that power is it manages everything in the stack. It wants to control everything. It has to make assumptions about how everything is set up. And so it ends up tightly coupled to the server abstraction. So if you want to run it up there in functions, you might run into some issues. We've discussed now a few examples of that, and now you have the tools to start thinking about what else you might run into. So, what does this mean, you employee of a big cloud provider? Are we saying that functions and Rails don't mix? Are we saying that, sorry, these function servers are never the right solution for Rails? No, I'm not saying that. For some Rails applications, functions as a service can work. It can work very well. It can be very effective. And it's not difficult. Google's Cloud Functions uses rack as the interface, so it's pretty easy to write a function that just turns around and calls Rails. In Lambda, it's a bit trickier because it has a different argument type, but you can still do it. There's a great project out there called Lambda that will help with that integration. It also provides a bunch of features for hooking into AWS, so check it out. Getting the basics working with functions in Rails is not hard, but it's still important to understand the trade-offs. Rails is designed for a very different infrastructure. So if you're considering Google Functions, if you're considering Lambda, think about what parts of that infrastructure that you need to interact with. And the more that you can fit up there where the function abstraction lives, the better off you'll be. What about containers? Well, as we saw, there's a lot more overlap between containers and traditional servers. There are a few differences. Startup and shutdown is different. Process handling, some of the file system is going to be different. But in practice, things usually tend to work pretty well for Rails and containers. And that's why I think we've seen Kubernetes become really popular in our community. And I expect that other container-based products like Amazon Fargate, Google Cloud Run, Knative-based services, and so forth, I expect these to continue to be very effective for Rails. So for typical Rails apps, I tend to like container-based services. Functions, maybe not so much, but again, these are generalizations. These are my opinions. For your app, think about what abstractions you're depending on. How well do those abstractions fit with the hosting product that you're considering? Now, all this brings up one final very important question. When cloud platforms developed this idea of abstracting a server, it was brilliant. It was a revelation. But it also shone a spotlight on a really big issue, which is that a server is actually a terrible abstraction. It's way too big, way too complex. Software engineering, we're trained to create simple, small interfaces. A server is none of that. And we can see the effects of that and how difficult DevOps is. I mean, DevOps is just way harder than it should be. That's because of servers. So I think we need these new abstractions. We need to be developing smaller, better abstractions of infrastructure. So containers, functions, maybe in the future new ones that we haven't thought of yet. We need them. We need these. They're not gimmicks. They're not going away. They're only going to become more important over time because we need to move beyond servers. So this brings up a very important question for us. How do we, as the Rails community, respond to this? As Rails developers, what do we need to do in our apps, in our code, in our practices to keep up in a world of new abstractions, in a world that is moving beyond servers? Well, here are a few practical thoughts for your code. Make initialization faster. Do less during initialization, less pre-computation, less cache warm-up, spend less time. Defer initialization. Rather than starting up or setting up a resource at app startup, consider initializing it lazily. Wait until the first time a request actually needs it, because cold starts matter. And they're going to matter more in this new world. Be web server agnostic. Don't tie yourself directly to Puma or Unicorn or Passenger or any particular system that has deep dependencies on the server. Background threads. Just don't do it. Unless your threads are tightly scoped to a request, better just not to use them at all. If you need to run stuff asynchronously, consider task queue or some similar mechanism. The file system. Use it less. Parts of the file system may be slow, remember, or might not even be writable at all. So avoid it as much as you can. Don't use the file system as scratch space. Definitely don't use it to persist data. Use a database or a storage service for that. If you really need a temporary file, use Ruby's temp file class. Don't assume that you can just create a temp file anywhere. Don't log to files. Log to standard out or standard error. If you have to interact with the file system, use the file utils library rather than shelling out to file commands. And in general, use Ruby's standard library interfaces rather than reaching into the operating system. Another example, use Ruby's random number classes rather than dev/urandom. The reason it's important to use Ruby's standard library is because these hosting products might need to configure Ruby to make sure that it works well with their environment. But this is only going to help you if you use the Ruby's standard interfaces. So don't bypass them, use them. And of course, tips like this also apply if you maintain a gem that gets used with Rails apps. Your gem needs to be able to play nice in a world of smaller abstractions. So users of your gem will have a better experience. Finally, let's take a look at Rails itself. Now, as we've seen, Rails is pretty server-oriented. Now, I don't think it's necessary or even desirable to change that at this point, but one thing I think would be helpful is to improve its modularity. We need to make it easier to use part of Rails without having to bring in all of Rails with all of its server dependency. For example, I sometimes find that action view by itself would be really useful for writing functions. And not just for functions, actually. I also work on a code generator that uses action view internally. And I really wish it were easier to use it, just the action view gem by itself, without having to pull in all of ActionPack and all of Railties along with it. So a more modular Rails, a more flexible Rails, I think would make us more successful in the world of new abstractions. So I hope we now have a better understanding of what's really going on with these new deployment options, especially the ones that might label themselves as serverless. Now, I should acknowledge that this stuff is constantly evolving. A lot of this technology is still very new. The products are evolving, the ideas are evolving, the best practices are definitely evolving. I'm finding myself giving different advice this year in 2021 than I did last year, and I totally expect to make more adjustments next year. So it's important for all of us to continue the conversation, to continue to learn. So Let's continue to do that. Continue to explore, try things out, share our findings, and move forward, having a better understanding of the pros and cons. Again, my name is Daniel Azuma. If you're here at the conference, there should be a link to the session chat below this video. So please join in. I'd love to talk to you about infrastructure abstractions. In my day job, I work on Ruby at Google Cloud. If you're interested in that area, I'd love to talk to you about that as well. Otherwise, thank you for watching and have a great day at RailsConf, at home, with your kids and your pets.